Good day. Today we are looking at how the main memory and the cache memory work together. Everything in the computer memory takes the form of basic units called bits and binary digits. Each is stored in a memory cell that can switch between two states. That's possible values, zeros and ones. And millions of the zeros and ones are what make up computer files. See, main memory is the primary storage for active programs and data, typically the DRAM with large capacity but slower access time, that's tens of nanoseconds. The cache memory, a small, fast memory, SRAM located closer to the CPU with low latency. It stores frequently accessed data or instructions to reduce the time the CPU waits for data from the main memory. Cache sizes range from kilobytes to few megabytes. The main memory, the time or period is known as memory latency because memories in the short-term memory can be accessed in orders known as RAM, random access memory. Most common RAM uses the dynamic RAM. In the dynamic RAM, memory cell consists of tiny transistors and a capacitor that stores electrical charges, 0 when there is no change and 1 when there is such change, so making it dynamic. It holds charges briefly before they leak away, requiring periodic recharging to retain the data. Even its low latency of 100 nanoseconds is too long for modern CPUs. So there's also a small high-speed internal memory cache made from the static RAM, usually made up of 6 interlock transistors, which doesn't need refreshing. SRAM is the fastest memory in a computer system and is 3 times expensive than the DRAM. It was introduced as a storage place for frequently used instructions required by the CPU, because the instruction needs to go from the main memory and get loaded back into the CPU. Obviously, as I have my mockup on the main memory into the CPU. But with the cache memory, instructions need to go from the main memory and get loaded back into the CPU. It takes time from the CPU to the main memory. That's why the cache was introduced. In order to solve this issue, cache is introduced which frequently access info or instructions. Have you seen? So CPU to memory, long distance, then before it comes back. But the CPU to the cache, then it's retrieved quickly. Then if there's nothing in the cache, it goes to the main memory, then it's retrieved and it goes to the cache and comes again. Have you seen the process? It's longer. In the main memory and the cache memory working together, they bring about balance of speed, balancing in speed, capacity, and cost. So they looked at the purposes of cache. Cache has a high speed buffer between the CPU and main memory, since the CPU processes data much faster than the main memory and can supply its cache stores copies of frequently used data, as I said earlier. So when it comes to data access process, cache hits when the CPU requires the data and instruction is sent. It first checks the cache if the data is in the cache and retrieves it quickly, as I use the mockup to explain. Sends to the cache. If it's there, it retrieves it quickly. If it's not there, that's a miss. Then you go to the main memory before it will retrieve the data. That's the cache miss. So we go to the low latency. Temporal locality programs pretend to reuse data or instructions recently accessed. Cache keeps these items for quick retrieval. Spatial locality programs often access data near recently used data. Now we have a data transfer. When a cache miss occurs, the system retrieves a block of data from the main memory and stores it in the cache. If the cache is full, replacement policy, LRU, decides which data to evict. Now we look at the write operations. Writing through, data is written from both cache and main memory simultaneously, consistently but slowly writes. Write back, data is written only to the cache memory marked as dirty. Data coherence, performance impact. And one of the key benefits they have working together is speed. Cache reduces latency, efficiency, scalability. And the challenges are cache misses, coherence, and the cost. As you are aware, the SRAM is 3 times expensive than the DRAM. So when you introduce the cache, it makes everything much faster. So working together helps everything much faster. Helps improve the main memory. So this is how the main memory and the cache work together. Thank you.